Hi and welcome to episode 4 of my DIY smart home series. Last episode, we covered a whole lot about Home Assistant, custom components, and lighting controls, but this time is all about making my heating even remotely intelligent. And that starts with this. This is the Mohs BHT-002-GCL-ZBW. It's a Zigbee-based thermostat, and also two of these Sonoff SN7B02 Zigbee temperature and humidity sensors. Assuming you already have Home Assistant up and running, as covered in episode 2, and a Zigbee dongle, also in episode 2, this is pretty much all you need. Getting these tiny temperature sensors up and running is super easy. You pop the back off and remove the sort of battery isolator tab, then stick the included 3M adhesive pad on the bag, and then stick it somewhere. Ideally not next to a heat source like a radiator, but somewhere that can get a representative sample of the room's actual temperature. As for the thermostats, well, there are a few things that you need to know. First, make sure you get the right model. As shown by the silkscreen on the sort of interior sort of screen PCB, this comes with either Wi-Fi, as the name suggests, or in my case, Zigbee for communication with other devices. I can't stress this enough, make sure you get the Zigbee version, not the Wi-Fi one. To see why, check episode 1 of this series. On top of the connectivity, there are also actually 3 different versions or models of both the Zigbee and Wi-Fi models respectively, and again, you'll need to be careful to get the right model for your setup. My boiler only needs 2 wires, basically just connecting together like a switch, but if your boiler, especially electric water heating style units, need to actively be powered through the thermostat, then you'll need a different model to the one I'm using here. I picked up the C model, as in GCL-ZBW specifically, rather than the A or B versions. This one takes 4 wires in: live, neutral, dry contact 1 and dry contact 2. Those dry contacts are the 2 wires from the boiler's room stat pins, although seeing as I'm not a qualified electrician or plumber, I'm going to refrain from giving you pretty much any advice on actively installing this yourself. I'm confident enough in my knowledge and experience and understand the risks involved enough to install this myself, but I'm not confident enough at all to be giving out any advice on doing so. This is legitimately dangerous. Hell, even the dry contact pins from the boiler are live at mains voltage, so if you aren't sure, just have a professional do this for you. Now, once you have it all hooked up, you will want to have the thermostat powered on, but switched off so that the screen is blank and the LED ring in the middle is orange. Then hold the down arrow for around 8 seconds. The screen will start flashing with a little sort of Wi-Fi type logo on screen, and then you can head back to Home Assistant and via the Zigbee Home Automation integration, search for new devices. You can also press the little pairing buttons on each of your sensors or your temperature sensors too, and they will pair up as well. Home Assistant will automatically find and connect to, well, them all, and will even automatically add them to your Home Assistant controlled dashboard. And yeah, it works exactly as expected. Perfect. Except it's not all that smart. Sure, it's connected, I can control it from my phone from the Home Assistant Android app, but it only bases its control on the temperature sensor built into the thermostat, not the temperature sensors we've connected and installed. Now, much like the lighting control in the last episode, there are a million different ways to automate this to achieve some pretty similar results, but for the purposes of this video, I want to walk you through some slightly more advanced automation methods. Now, Home Assistant itself has automations built in. They aren't the most user-friendly, but it's worth having a quick peek at. On the automations page, when you click the Add Automation button, you'll be asked if you'd like to use a blueprint or start fresh. Blueprints are basically automations that other people have already created, and you can just tell it what devices to use, maybe tweak some minor settings, but otherwise it's kind of set up and ready to go, whereas starting from scratch means that you have to build it yourself. Here are the three main sort of areas or things that you'll need to know and to set up: triggers, conditions, and actions. Triggers are what starts the action. In our case, that could be, say, the temperature in my office gets too low, so once it does that, it will kick on or kick our automation into life. But only if all of the conditions are met, like the heating is already off, or the temperature is low enough to trigger that, or even if I'm home. Finally, there is the actions. This is what it will actually do, like turn the heating on. These are a little limited, or at least they are a pain to deal with, and personally I find them really unintuitive to actually work with and to set up, so let's use something else instead. That something else is an add-on you can find in the add-on store called Node-RED. Once you install it and likely restart Home Assistant, you'll also want to head to Hacks, the Home Assistant community store that we installed and got set up in the last episode, and install the Node-RED companion integration too. And also head to the integrations menu and add that integration, but once you've done all of that, you should be good to go. Node-RED is a flowchart style programming tool. You have little boxes with lines that you just click and drag between other boxes to connect them together. Now, I've already set up my main sort of flow, my main code, but let's start with a new one and a new tab so that I can explain the basics. On the left, you have all of the nodes that you can use, grouped in sections like Home Assistant or Common. In the middle is your code space. This is where you drag new nodes into and hook them all up together. If you double click on a node in the middle section, you'll see its properties appear on the right hand side, and further right of that is more information, although you'll want to click on the little bug icon tab at the top right, as that is the debug console, which is your best friend when building these new flows, this code or automation. For debugging purposes, the Inject and Debug nodes are the two that you will use the absolute most. Inject basically gives you a button in this window that you can press to trigger your sort of code, rather than, say, having to wait until 3 AM and the temperature in your room drops below your given threshold for your existing triggers to fire off. And the debug node, well, that dumps information to that debug window on the right so that you can see what's going on. The main idea is that these nodes pass messages along the chain, along the wires that you draw between them. See, if I open the Inject node and add a new item, let's call it data item, and the value can be a little message, a little bit of text. And now if I hit deploy, which is kind of the save button in this environment, and then click that little button on the Inject node, well, boom, we have a little message that came through to the debug node under that msg.dataitem heading, and it appeared in our debug window. You can also do conditional tests with these switch nodes. Say I add a boolean, a true-false value, call it show data, and tell the switch node to look for that value, that boolean, and only let the message through if the show data value is set to true. Well, now if I deploy that and hit the button, yeah, it still works. Our message comes through to the debug window just fine. But now if I change that show data value to be false and deploy again, then click the button, yeah, no, the message doesn't get through as expected. You can also get information from Home Assistant devices, like our temperature sensors. You just drag that node in, pick your device, and that's pretty much it. I'll add a switch after that as well to check if the temperature is, say, less than 22 degrees Celsius, and hit deploy, and yeah, it's all good. Our message comes through fine, thanks to the temperature being, I think, 21.7 degrees Celsius. But now if I swap that switch to look for anything under 20 degrees, well, now the message doesn't come through because that condition isn't met, even though our earlier condition, that true or false, is still met just fine. Of course, you can also set values or write out of this code rather than just read in using nodes like the call service node, which is what I use to actively set the target temperature for the thermostat, or even just turn it on or off. There is a lot of depth to this that I can't really go into, mostly because I don't know all that much. I've only been playing around with it a little, but also because how you want to set things up is very much dependent on what you want out of your your automation. So I'll leave that bit so that the further research and learning and having a play to you. But what did I do? Well, instead of, say, triggering it manually, I used a pull state node to check the temperature readings from both of my temperature sensors with the condition that it should only output a new message, only actually trigger things when it is above or below any given threshold for each of those nodes. Also, it only updates once per minute, both for sort of saving battery life and because the sensor itself generally isn't going to update all that regularly anyway. Since I only want the bedroom temperature sensor to be considered when I'm actually in bed, I have a time range switch, which then outputs to a current state node, which gets what the current temperature the thermostat is both sensing and is set to, and passes that to a function node, which is a little block that lets you write custom JavaScript code, which in my case I just use to alter the set temperature up or down by 1 degree Celsius at a time, and then have that output the new temperature, which I pass to a call service node to actually set the thermostat to that new temperature. There is plenty more that I want to add to this, including checking if mine and my wife's phones are connected to Wi-Fi, and therefore if we're home or not, and generally, keep the heating low or off, save energy, and also add things like more temperature sensors and even the smart TRV or thermostatic radiator valves to control each room's temperature independently. That'll be great, as say at night I can close all but the bedroom valves so that any heating that goes on is exclusively only heating us in the bedroom and not being wasted on the rest of the empty house. But say during the day, only the rooms that we'll actually be using will be heated to again help save on those ever-increasing energy costs. So that is a look at both how to set up a smart thermostat and temperature sensors, but also how to start kind of having a play with custom automations, both in Home Assistant itself and through the visual programming tool Node-RED. Next episode, I'll be walking you through how to make your Home Assistant system accessible from anywhere on the internet, securely and privately, so make sure you're subscribed so you don't miss that one. If you want to pick up or just check out either the thermostat or the temperature sensors or even the Zigbee dongle, I'll leave Amazon affiliate links to all of those in the description that you can check out. Like I said, those are Amazon affiliate links and they'll take you to your local Amazon store. We can see pricing when and where you watch this and pick them up yourself if you fancy. If you want to check out any more videos, including the rest of this series, if you haven't seen it already, do check out the playlist on the end cards. And of course, I have plenty of other tech videos on the channel as well that you can take a look at. If you want to support me in these videos and the channel, you can do so directly through YouTube and become a YouTube member and get some cool rewards for doing so, or support on Patreon instead if you'd rather. You can also just pick up a hoodie or t-shirt like this one, or a load of other designs that I made myself, or even just use the affiliate links that are in the description for places like Overclocks UK, the Amazon ones, or a load of other stuff, even some VPN options. There's a load for you to take a look at, so feel free. Otherwise, if you have any questions or things you want to see covered in this series, then feel free to let me know in the comments. Thanks for watching. We'll see you on the next video.